Every moment of life on Earth depends entirely on a single engine. The sun produces the thermal radiation that keeps our water liquid, and the gravitational mass that keeps our planet in a stable orbit. Consider what would happen if that engine abruptly vanished from existence. Because both solar light and gravitational pull travel through space at roughly 186,000 miles per second, the planet would not react instantly. We would carry on, completely oblivious, for exactly 8 minutes and 20 seconds. During this eerie window of normality, the final photons emitted by the sun would continue their journey through the vacuum of space, illuminating a world that is already doomed. Once those last rays hit the atmosphere, total darkness swallows the globe in an absolute instant. Because our perception of the cosmos always operates on a delay, the true terror of this scenario lies in the complete lack of physical warning. At the exact moment the light fails, the gravitational tether snaps. The invisible forces holding the inner solar system together disappear. Earth immediately releases from its orbital curve, shooting off in a straight line into deep space at 67,000 miles per hour. Looking up, you would see the moon and our neighboring planets fade into nothing, as they no longer have any solar radiation left to reflect. The only natural illumination left above us comes from distant, freezing starlight. Down on the surface, survival immediately depends on local electrical grids. Earth is demoted. It is no longer part of a functioning solar system, but rather a rogue projectile flying blindly into the void. Without solar heating, the global surface temperature plummets by an average of 0.8 degrees Celsius every single hour. This sketch captures Salem, Massachusetts, during the devastating Year Without a Summer. In 1815, volcanic ash from Mount Tambora partially blocked out the sun, triggering fatal crop failures and widespread famines across the northern hemisphere. A total loss of the sun creates a much more violent dynamic. As the planet rapidly cools, the physical density of the atmosphere shrinks and drops closer to the ground, generating intense wind currents rushing from the freezing poles toward the equator. The compressed atmosphere also begins to physically separate. Heavier elements drift down, while lighter, breathable gases rise, destroying the air balance worldwide. Simultaneously, the atmospheric water vapor forcefully condenses, rapidly burying all global infrastructure beneath apocalyptic, unyielding hyperblizzards in total pitch-black darkness. Long before starvation claims the population, the collapsing weather systems turn the sky itself into a lethal weapon. At ground level, photosynthesis ceases immediately. Plants can no longer convert carbon dioxide into oxygen, destroying the foundation of the global food chain. The timeline of extinction moves quickly. Plant life dies within weeks. Herbivores follow soon after, starving out the carnivores, and leaving only the scavengers to delay the inevitable. By the end of the first year, the global surface temperature stabilizes near negative 150 degrees Fahrenheit. This diagram illustrates the ocean's response to the freeze. The extreme cold hardens the upper layers of water, turning the world's oceans into a thick, planetary ice rink. Beneath that ice, however, Earth's hot internal core keeps the deep water liquid for millennia. Down at the hydrothermal vents, isolated colonies of microbes continue to thrive, perfectly indifferent to the dead sky above. The surface biosphere is erased. The Earth's habitable zone flips entirely, relocating from the bright continents to the pitch-black ocean floor. For humans to survive negative 150 degrees, the surface must be abandoned completely. Our only option lies in the geothermal gradient. Away from tectonic boundaries, the crust's temperature naturally rises about 1 degree Fahrenheit for every 70 feet of depth. To reach 75.5 degrees, humanity must construct enclosed habitats 1 mile underground, tapping directly into the massive thermal energy of the Earth's core. Our species would have to adapt to life as subterranean scavengers, sustained entirely by the radioactive heat radiating from the center of the planet. The sudden disappearance of the sun makes for a fascinating thought experiment, but the actual scientific threat we face is exactly the opposite. Our star operates by fusing 600 million tons of hydrogen atoms into helium every second. That fuel supply is finite. In roughly 3.5 billion years, as the core shrinks and nuclear reactions accelerate, this intense, inescapable solar radiation, Earth's oceans will permanently boil away into a baked, Venus-like wasteland. By the 5.4 billion year mark, the Sun exhausts its hydrogen entirely, expanding into a massive red giant that swallows Earth. Finally, the dead star collapses into a white dwarf, a dimming core cooling in the dark. Whether our world freezes in sudden darkness or burns in inevitable light, human existence remains fragile. Our survival is a temporary privilege, dictated entirely by the life cycle of a single star.